In the previous video, we talked about the different forms of naturally occurring radiation from an unstable isotope. So we had a look at alpha radiation, beta radiation, and gamma radiation. And we said in gamma radiation, for example, that it emits electromagnetic waves. And so in this video, we're going to have a little bit of a deeper look into what exactly is an electromagnetic wave and how does that spectrum look. Light is just a small part of the spectrum of electromagnetic waves. So the light that comes from the sun only forms a very small part of the electromagnetic spectrum. It is the visible light that we can see. Our eyes cannot detect any other part of the visible spectrum. And to be honest, the world would appear very, very different if we could see other forms of electromagnetic waves. For example, all objects emit infrared radiation, and here on the right we have an image of an infrared camera which can see objects in the dark. So if this image was dark instead of in the day, that image on the camera would look exactly the same because the house is emitting infrared radiation from it. In a vacuum, all electromagnetic waves travel at the speed of light, which is denoted with the letter c, and that equals 3 times 10 to the power of 8 meters per second. So it's an extremely fast property. And as you know from GCSE, the wavelength of an electromagnetic wave of frequency f, which equals the frequency, is given by the following equation. We have the wavelength equals the speed of light divided by the frequency. And that is our key equation here. And also note that whenever we talk about the wavelength, we almost always want to express it in nanometers, and 1 nanometer equals 1 times 10 to the negative 9 meters. So it's an extremely small number because the wavelength of an electromagnetic wave tends to be extremely small. And we can see how this works looking at the electromagnetic spectrum and seeing the different types of light. So note a moment ago I said that the main ones that we can see, the main type of electromagnetic waves that we see is the visible spectrum, which falls somewhere in the middle, of our spectrum. So let's say we had different wavelengths of light, a different wavelength of electromagnetic waves. We have visible light somewhere in the middle, of this. And then either side we tend to have like infrared. As we move towards the left-hand side of the spectrum, and as the waves tend to get progressively larger, so the wavelengths will probably look something like this. It's quite a long wavelength at the top here, and then there's a shorter wavelength over this side of the spectrum. So we've got infrared, and we've got like microwaves over here, and we've got something like radio waves perhaps all the way over this end of the spectrum, And then moving towards sort of the smaller end of the spectrum where the wavelengths tend to be a lot shorter, we've got ultraviolet, UV, we've got X-rays, and then finally we've got stuff like gamma rays, which we talked about in the previous video, And obviously the wavelength of light, and we're going to express it in nanometers as I just mentioned, tends to be around 400 to 700 nanometers. And then you can look this up yourself. I won't write this all out, otherwise it could bore you, but this will go up to around less than, 1 nanometer, all the way up to above 0.1 meters. So that is substantially larger than a gamma ray. So that should give you sort of a good indication of how the spectrum differs and the different types of electromagnetic waves that there are, and obviously the only one that we could detect with our eyes is visible light, but there are all these other types of electromagnetic radiation. Electromagnetic waves consist of an electric wave, as we see here, an electric wave and a magnetic wave. And they travel together and vibrate at right angles to each other and to the direction in which they are travelling. So you can see that they're at right angles to each other. This one's going up this way, this one's going across this way. I mean, it's not very easy to represent on an image, but they are at right angles to each other, and they're also at right angles to the actual direction of travel too, which is across this way. The other thing is that the waves travel together and vibrate in phase with each other, and you can see this as they reach a peak and they are in step. So when waves do this, we say they are in phase. So here we've got the magnetic field, it peaks here, and the electric field peaks here, and they do this all the way throughout their journey. So they are always in phase with each other. So this video is a very quick introduction into electromagnetic waves. We taught you a little bit about the different types of electromagnetic waves within the spectrum and the different ranges of wavelengths across the spectrum, and also we had a little look into what exactly an electromagnetic wave consists of. So in the next video we're going to move on from this towards a discussion about photons and how photons work alongside our understanding of electromagnetic waves. If you have any questions at all, please leave a comment below and I'll get straight back to you. Thank you very much for watching.